Okay, can all of you see my shared screen now? Okay, so here's the problem. So you have two random variables, X and Y. And each of them are uniform within the interval 0 and 1. Okay, so it's better to use the open brackets as it is the continuous random variables, uniform within the interval 0 and 1. So we have to find the PDF of the random variable u, where u is x plus y. Okay, so both x and y are IID, that means they are independent and identically distributed. The distribution is uniform in between 0 and 1. Okay, so you are familiar with the uniform distribution. If x is following a uniform distribution within the interval, let's say alpha and beta, then the PDF of x is going to be 1 over beta minus alpha. That means the total probability 1 be divided equally within all the points in the interval alpha and beta. So if you have alpha and beta, the total probability will be divided in between all the values in the interval alpha to beta. So the length of the interval will be beta minus alpha. So that will be the probability that you will get for each and every point. Okay. So X will have values in between alpha and beta. So this is how we write the uniform density. Now, since we have 0 and 1, alpha is 0 and beta is 1, therefore we can write our PDF for X separately. That will be 1 within the interval 0 and 1, because the length of the interval 0 to 1, that is 1 over 1. Okay, so it is going to be 1. And similarly for the random variable y, okay, so that will be the same. Okay, and it is given that it is IID, that means they are independent. So X and Y are independent. So which means if you want the joint PDF, now remember when you are finding the sum or the difference quotient or the product, you need the joint density of X and Y, okay, in order to apply to that formula. Okay, so you need the joint density. Since you know X and Y are independent, the joint density of X and Y, that will be the product of the marginal densities. So you already know the marginal densities. So the product will be just 1 times 1. Again, it is 1. So you can write the joint density of X and Y, which is the product of the marginals, which will be simply again 1. Now both X and Y will be within the interval 0 and 1. Okay, so that is very simple. Right. Now that is the joint density we have to use when we derive the density function of their sum. Okay. Now can you remember when you have x plus y for u, we already proved that the density function of u will be x going from negative infinity up to plus infinity. The limits will change according to the problem. We'll see how that limit will change, but here's the common expression. This we already derived, right? So we already know this, and this is proven result. So here's your joint density of x and y written in form of u and x. Okay, so let's see how we can replace this joint density with the joint density we have. Okay, right. Now we already know x is in between 0 and 1. Y is also in between 0 and 1. And when you add them together, what will be the limits? What is the minimum and the maximum that any value x plus y can have? What is the minimum and what is the maximum? What do you think? The minimum that x can get is 0. The minimum that y can get is 0. So when they add, what will be the minimum? And the same thing, you can go for the maximum. X can go up to 1, y can go up to 1. And when you add them together, what will be the maximum value the sum can get? Can you get the limit of x plus y? Which is actually u. Yes. So if the smallest value x can get is 0 and the smallest the y can get is 0. So when you add together, the smallest that the sum can get is also 0. What about the other side? If x can go up to 1, y can also go up to 1. What is the minimum, the maximum value that their sum can get? Yes. Anybody who want to try? Yes, it should be 2. Yes. Okay, so it's going to be 2. So u will be in between 0 and 2. Okay. Now if you write our u, which is x plus y, in form of y, because now we have to replace y here, right? We have to replace y. So what will be y? U minus x. So that is that we already know. Okay, yeah, we got the answer. Great. Okay, so let's try to write down this joint density. Okay, so this is the joint density of x and u minus x, where our u minus x is y, right? So we already know the joint density of x and y, right? So let's try to replace it. Okay, right. So our fu will be x going from negative infinity up to plus infinity. Okay, but we know that this is y, right? And this negative infinity, actually, we can restrict it up to 0 because we know x is from 0 to 1, and this will go only up to 1. Okay. And this joint density of x and y, or y is our case now, u minus x. Since we know these two are independent, x and y, we can write it as the marginals, the product of the marginals. So what will be the product of the marginals? Fx separately, and then fyy, but our y is u minus x. Right? You can do that. So instead of this joint density, we replace it with the product of the marginals. We are doing that because our calculations becomes easy because we already know the limits of x. Okay. Now we can do that. Why? Because x and y are independent. We already know it. So the joint density can be written as the product of the marginals. Now look at this fx. Right? Look at this fx, and we already know this x will go from 0 to 1. Now what will happen if you integrate fx from 0 to 1? What will be the answer? The support of x is from 0 to 1. So if you integrate the density function from 0 to 1, what will be the answer? Okay, that is the rule of probability distributions. If this is a proper probability density, what should happen if you integrate over the support of the density function? What will be the answer? That should attain the total probability 1. Okay, so if you integrate fx, the PDF of x from 0 to 1, it will be 1. Okay, why? Because we know x is from 0 to 1 and it is uniform, it is 0 otherwise. So the fx will be just 1. So we can replace this fx. Okay, so we can replace this fx by 1, right? Because it is from 0 to 1. So that is the total probability already obtained. Therefore, we can rewrite our fu as this. Okay. Since fx is 1, we can simply, if you want, you can write 1 here, but you can simply omit it. And our limit is now from 0 to 1. X is from 0 to 1. And fx, it is 1. So we don't have to write it anymore. We simply write the rest of the function. So that is what we have to solve now. Okay. Now let's think about our u. Right. So here's our number line. We already know that u will be in between 1, 0, and 2. Right. So the limit of the u will be from 0 to 2. Now look at this, the integration. We have the letter y. Actually, this is the density function of y written in the form of u and x, because we are integrating with respect to x. Right. So our variable, we wrote it in terms of x, which will be u and x. Okay. So when y is from 0 to 1, okay, so that means u minus x is from 0 to 1. Okay. Now, what will happen to x? What will be the limit of x if you have u minus x in between 0 and 1? Now that we are looking in terms of y. Okay. Now we know that u minus x is in between 0, 1, because that is y. Now, according to this limit, what will be the limits of x? So you have to throw away the u to the other sides, and the minus sign should be slipped to the switch to the positive. And you will end up with, you can try this, you will end up with x in between u minus 1 and u. Right? So simply, if you take this x to the other side, you get x less than u minus 1. If you take this x to this side, you get x less than u. Very simply, you can get the limits of x. So x will be from u minus 1 up to u. So what does that mean? So let's draw this number line again. Here's 0, 1, and 2. And if you want, you can write -1 also. Right? So we already know that u is in between 0 and 2. And what will happen to u minus 1? The u minus 1 will be in between -1 and +1. Right? So you can try it. If u is from 0 to 2, what will happen to u minus 1? Okay, so if you subtract 1, it will go from -1 to +1. Okay, that is also obvious. Okay. Now, in order to find this integration, our final goal is to get this integration done. Okay, so that will be the answer of FUU, right? We know that x is from 0 to 1, okay, but u is from 0 to 2. Okay, u is from 0 to 2. So let's split our u 0 to 2 into 2 intervals. So in that case, we can do the integration very easily, okay, and see what will happen to x within the two regions. Okay, the two regions that we are going to look at is from u in between 0 and 1 and u in between 1 and 2. And these two situations, we'll see what will happen to x. And according to that limits of x, we are going to replace the limits of x. Okay, and then let's find what will be our FU. Okay, so let's do it in two separate cases. Okay. So our case 1 is when u is in between 0 and 1. Okay, you can use the equal sign if you want. Anyway, it doesn't matter. These are continuous random variables, right? So when u is in between 0 and 1, okay, we already found that x is in between u minus 1 and u. Okay, u minus 1 and u. So let's try to write down the case 1, right? U minus 1 up to u. Okay, I'm going to split it again like this. U minus 1 up to 0. Okay. And what will happen to our FYU minus x? So that will also, we have to show that this also goes to 1. Why? Because y is in between 0 and 1. Okay. So what we have is just 1 actually, right here. Right? So it is very similar to the previous one. Fx is also from 0 to 1. And this is also, if you integrate from 0 to 1, so that will go to 1. Okay. So what we have is just 1 actually. Okay. So what we have is just 1. So that is the nice thing about the uniform distribution, right? So that is from u minus 1 to 0. And you can always split like this. Okay, your integrals, you can always split like this, 0 to u dx, right? Now it is very easy to do the integral now, right? When we are considering the region u from 0 to 1, that means x will be from u minus 1 up to u. So we again split it into 2. That is just to make your integration easy, okay? Now what do you think? Now remember, this integration is with respect to x, okay? So although we are using the u, that is our transformation, but our integration is with respect to x, okay? Now when x is from u minus 1 to 0, what is the probability? What is the probability of x when it is from u minus 1 up to 0? Now remember the distribution of x. X is in between what? 0 and 1. Right? This is the probability distribution of x. Anything beyond 0, the probability is 0. Anything beyond 1, again, the probability is 0. So if you have x less than 0, right? So this is less than 0 area. So u minus 1 will be somewhere here. So what is the probability inside that area for x? That is 0. So nothing is going to included from that region, and that is exactly why we divide this integration, split it in from 0, because 0 is the lower limit. Anything beyond that, that is 0. So that part is gone. So you have to integrate only x from 0 to u, and that will be what? Simply u, right? U evaluate from, this is, I'll write it, x evaluate from 0 to u, which will be u. So if you want, you can write that separately. FUU will be u within the interval 0 and 1, right? So that is u in the interval 0 and 1. Now we have to go to the next part, which is u from 1 to 2. So that is our second case. If u is from 1 to 2, right? Now if u is from 1 to 2, where will x go? X, right, is still in between u minus 1 and u. Okay, it is still in between u minus 1 and u. Now in this case, it is from 1 to 2. So we are going to split it from 1. Okay, why? Because we already looked at the things beyond 0. Now we are going to look at the things above 1. Okay, so what we are going to do is u minus 1 up to 1. Still we have density 1, and x going from 1 to u. Now what we have done, we have split the interval u minus 1 up to u at 1. We split the interval from 1. Okay. Now what will happen? Now look at this one. We know that x is in between 0 and 1. So anything beyond 1, it is 0. So if you integrate x from 1 to u, there's nothing. The probability is 0 in that area. See, it is 0 in this area. So the integration from that part, okay, it is 0. It is gone. So you have to only look at the integration from x u minus 1 up to 1. Okay, so what will be the answer? So it is again x evaluate from u minus 1 up to 1, right? U minus 1 up to 1, and the answer will be x is 1 minus u minus 1, and 1 minus 1, it is plus 1. So 1 plus 1 is 2 minus u. So which means FUU will be 2 minus u. What is the interval? In between 1 and 2. Now by combining these two cases, in the first one you have u from 0 to 1. The next case you have u from 1 to 2. They are not overlapping. So by combining case 1 and 2, you can write final answer for FU. That will be u in between 0 and 1, 2 minus u in between 1 and 2, and 0 otherwise. So this is the density of x plus y if they are independent uniform distributions. Actually, this is called the triangular distribution. Again, this is a well-known result. If you add two uniform distributions, you'll end up with a triangular distribution, and it will look like this. Actually, you can draw it. If you look at this, if you draw the straight lines, you'll see that it will look like this. It is going to be the triangular distribution. This is the f equals u. This is 2 minus u, right? Okay, so this is how you do the summation, right? So one example to show you how we can do the or derive the distribution of two sums. Now this is different than the previous one. We already did one example with exponential densities. That was actually easy, right? But when it comes to uniform distribution, it is a little bit different because of the behavior is different within the interval. So we split the interval into two, 0 to 1 and 1 to 2, and look at the behavior separately. Okay, and this is how you end up with the answer, right? So these are again proven results. So better study it and understand what we have done here, right? The main thing that you have to understand is when they are independent, you can write the joint in the product of the marginals, and they are the correct limit, x and y are uniform in between 0 to 1. So how these the one came actually because of the limits. So it is actually very easy, just integrating one all the time, but you have to look at the correct limit according to the transformation of u. Okay, so that's it. Right, so I will upload an assignment for you to practice these examples. Okay, some questions on how to find the sum, difference, quotient, and the product with few other well-known distributions. Okay, so you can try them and see whether you can find the answers. Okay, right. So that was about the first method, that is the distribution function method. Okay, remember we are going to talk about three methods. First one was the distribution function method, and then the second one we are going to start now, the method of transformation, and the third one will be the moment generating functions. Okay, so we looked at how to do the distribution function method for both univariate and the bivariate case. And remember that distribution function method is available only for continuous distributions. Okay, because we are dealing with integrations and derivatives, you can't do that with the discrete case. Okay, but now the second method that we are going to learn, okay, which is called the method of transformation, you can apply this to both discrete and continuous distributions. Okay, so this is the method of transformation. Actually, this is the most common method that we use in finding the functions of random variables. Okay, so actually this is easier than the distribution function method when it is applicable. Okay, so this can be used for both discrete and continuous. Okay, so let's start with the discrete case first. Okay, we are looking at the transformation method. For discrete random variables. Okay, let's start with the univariate one. That means we are dealing only one variable. Okay, univariate case. Okay, so in order to discuss this univariate transformation, first you should know this definition, and anyway you are familiar with this. You know what are one-to-one functions, right? You know what are one-to-one functions. Can you remember what are one-to-one functions and how you check whether a function is one-to-one? There are graphical methods that you can check it. right? There are other algebraic methods. Can you remember how you find a one-to-one function using a graphical method? I'll write the definition meanwhile. If you can remember how we find it graphically, you can put it into chat, or you can unmute and explain. Who can remember how you check it graphically? So this is the definition of the transformation method for one-to-one functions. Okay. Is this a one-to-one function? Is this a one-to-one function? Yes, what do you think about fx? Is fx a one-to-one function or not? Yeah, those who do mathematics major, you can answer this very easily. This is not a one-to-one function. Why? If fx is a one-to-one function, what should happen? For 1x, there can be only one y. Right? If you look at this, for 1x, you have two y values. That is wrong. So this is not a one-to-one function. Okay. In one-to-one functions, for a single value of x, there will be exactly one y value. So hope you can remember, this is how you draw one-to-one functions, right? Right. So one-to-one functions. Okay. Now, if you have one-to-one functions, okay, and suppose x is a discrete random variable and y is a function of x, gx. Okay, so y is a function of x. Then the PMF of y. So what is y? Another variable which is a function of x. It can be found by getting the inverse function of this random variable. Okay, so that is why we are defining this for only one-to-one function, because if you have to get inverse functions, they are defined for only one-to-one functions. Okay, otherwise you can't find an inverse, right? So the density of y can be found by the inverse of that function. Okay. Now this is very easy. You know how to get the inverse function. When you have x equals some equation, you replace x with y and isolate the x variable, and you can easily get the inverse function of x in terms of y. Okay. So this method is very, very easy. Okay. Anyway, let's try few examples and see how we can apply this transformation method for one-to-one functions first. Okay, so here's our first example. Now again, we have to be very careful. We are dealing with probability density functions. Okay, not just functions, probability density functions, right? So here's my first example. The random variable x, now this is discrete. This is the density function of x. X can have values 1, 2, 3, 4, 5, and 6. And you already know what will be this experiment. What is this experiment? This is rolling a balanced six-side dice. Okay, if you roll a balanced six-side dice, each and every side of the die can get the probability 1/6. We want to find the PMF of y. Okay, where y is 2x plus 10. Right? So y is 2x plus 1. So this is our gx now. Okay, y is a function of x. What is the function? 2x plus 10. Right? And you can clearly see that this is the straight line, so it is 1-to-1. So you can easily apply this transformation technique, right? Now in this example, you don't see x in your px. Do you see x? It is just 1/6, just the number. So when y is changing into 2x plus 10, the probability is it going to change? You don't see any x, right? So when x goes from 1 to 6, depending on the transformation of gx or the function of gx, you can find new values of y. But what will happen to the probabilities? Will it change? The probability is simply 1/6 all the time. It is not going to depend on the value of x. Okay. So therefore, if you find the density function of y, the probability will remain same. The probabilities are going to be 1/6, simply because this probability is independent of x. So when y changes, there's nothing to change in the probability, but the support will change. Why? When x is 1, what will happen to y? When x is 1, y will be 2 times 1 plus 10, which is 12. When x is 2, what will be y? 2 times 2, 4 plus 10, 14. The support will change, but the probability will remain same, simply because this does not contain an x term in our probability. Okay, so shall we write down the PMF of y? So this is the PMF of x. Right, so what will happen to y? If you do this transformation, you can find the new values of y that will be from 12, 14, 16, 18, 20, and 22. Right, so you can try them one by one. So when x is 6, what will happen? 6 times 2 is 12. 12 plus 10 is 6 plus 2 is 12. So 12 plus 10 is 22, like this. And what will happen to py? As I mentioned, the probabilities, they are not going to change. It's independent of x. So it is just 1/6 again. So this is the answer of the PMF of y when you transform x into 2x plus 10. Okay, is that clear? What we did here? So if your probability densities contain the value x, then of course you will get different probabilities, right? You will get different probabilities. But in this example, the probabilities are just a constant number, 1/6. So you are your final answer will look like this. Okay, is this clear to all of you? Have you got py? Okay, let's move on to another one. Now this is going to be a little bit different. So here's my x. The PMF of x (1/2 to the power x). Now your probability contains x, and x can contain values 1, 2, 3 up to infinity. So this is an infinite series, but discrete. Okay, discrete, only integers 1 through up to infinity. And I'm going to define the function for y. This is my function of y. Y will be 1 if x is even, and y will be -1 if x is odd. Now this is different than the previous one. You don't have a nice function for y, right? But y is defined as it will be 1 if x is even, -1 if x is odd, right? Now if you think about, okay, so let's say x equals 1, what will happen? When x equals 1, 1 is odd, what will be the value of y? Y will be -1. Okay, y will be -1. But that is only for when x equals 1. But we have to consider all these possibilities of x. X can be from 1 to 3 up to infinity. Okay, so we have to find what will be the values or the probability of y. Okay, these are the values of y. Okay, the possible values that y can get right? But we have to find py. Okay, so you have to find the py. So let's see how we can do that. So we already know that y can contain only two possible values. Either y will be 1 or y will be -1. When x's are odd, they will go to y equals 1 part. When x's are even, they will go to, -1. And when x's are even, they will go to +1 part. But there should be a probability for py. So what will be the probability of y when y equals 1? What will be the probability of y when y equals -1? So we have to find that. Okay, so let's try. Let's try a 1 by 1. When y equals 1, what will happen? So the probability y equals 1, what is x? X is even, right? So y equals 1 when x is even. So what are the probabilities? That means the probability x is even. That means x can be 2, x can be 3, x can be 4, x can be 6, and it goes up to infinity, right? Now let's find what are the probabilities. So what are the probabilities? So you can write this as the probability x equals 2, and when probability x equals 4, and when x is 6, in all these probabilities should be added, right? When x is even, the probability when x is 2 should be added to 1. When what is the probability when x equals 4 should be added to 1. So likewise, we have this addition up to infinity. Right, so let's try to substitute the probability. So what is the probability when x equals 2? It will be 1 over 2 to the power x. What is x? 2. So let's substitute it. This will be 1 over 2 to power x, but x is 2. And what will be the probability when x equals 4? It will be 1 over 2 to the power x. Now x is 4. So likewise, you will get the probabilities. And it will go up to infinity, right? So that means you have to get the sum of infinite series. This is the sum of infinite series. Now it has a common equation. Can you remember? Okay, so I have to make this 1 plus and the series. So let's do that. Take the common term out, which is 1 over 2 to the power 1. So you'll end up with 1 over 2. 1, 2 is gone. So this is 2, 4, 6, and so on. Okay, is this clear up to this point? We are taking 1 over 2 to the power 2 term out. So you get 1 plus 1 over 2 to 2, 1 over 2 to 4, and so on. Okay. So what is the common factor here? What is the common factor? What are we adding at each and every term? So I'll write it in this form, then you can easily see it. So what do you see here? 1 over 2 to 2, 1 over 2, 2, raised to 2, and so on. It goes like this, right? So what does that mean? What is our R? What is the common term that we are adding at each and every time? It will be 1 over 2 to the power 2. So that is our common term we are adding. And what is the sum of infinite series? For a common term R, that will be 1 over 1 minus Ry, because R is less than 1. Now this is from the series, the sum of infinite series. Okay, so I know you have learned these things earlier. So if you can't remember, just go and refer it back. Okay, the sum of geometric series, sum of the infinite series, when the common factor is less than 1, when it is greater than 1, there are different equations that we have, right? So go and refer them. You have learned these things earlier. Okay, so the sum of this infinite series, this will be 1 over 1 minus R. This whole thing will go to 1 over 1 minus R when n goes to infinity. So that means this part. Okay, this part is 1 over 1 minus R. Outside we have 1 over 2 to power 2. Right. So shall we substitute it? 1 over 1 minus, what is R? 1 over 2 to power 2, which will be 1 over 4. So what is the answer? Outside also we have 1 over 4. We have 1 over 4 minus 1 over 1 minus 1 over 4, which will be 3 over 4. Right? So that will give you 1 over 4. This 4 will cancel out. Final answer is 1/3. Okay. So what is 1/3? When the probability y equals 1. When y equals 1, okay, so when y equals 1, you get the probability 1/3. Is this clear to all of you? Is this clear to all of you how to get the infinite series, the sum and everything? This 1/1 minus r, you have to, memorize, refresh your memory, okay? Now we are done with y equals 1. Shall we try what will happen to y equals -1? When will that happen? Probability y equals -1 when x is odd. That means when the x's are 1, 3, 5, and so on. So again, we'll end up with x equals 1. Can be when x equals 3. It can be when x equals 5, and so on. So let's use the same method as previous. What is the probability when x equals 1? That will be 1/2 to the power x. X is 1, so it will be just 1/2. And when it is 3, it will be 1/2 to power 3. And then it will be 1/2 to power 5, and so on. So again, now you can see the common factor is 1/2. Take it out. So you'll end up with 1/2 to power 2, 1/2 to power 4, and so on. So again, you'll see that the common factor is 1/2 to power 2, right? Again, you use 1/1 minus r with r equals 1/2 to power 2. So what you get? 1/2 is still there. 1/1 minus r is still 1/2 to power 2. So can you simplify this and tell me the answer? What will be the probability when y equals -1? Final answer. You'll get 2/3. Yes, you'll get 2/3, right? Yeah, you get 2/3. You get 1 minus 1/4 is 3/4. So you have, you get 2/3. So you are done with the distribution function of y. So how do you write it? So here's my y, here's my py. When y is 1 and y is -1, this will be 1/3, this will be 2/3. And if you add, you get the total probability 1. So this is a proper probability density function. So that is my py after the transformation. Okay. Is this okay with everybody? Any questions so far? Okay, let's try one more example. So let's say our random variable x and here's my PMF. Px is again 1/2 to power x, the same PMF. But in this case, my y function is x to the power 3. Find the PMF of y. Right? Now this one you can easily use the definition, right? This one, you get the inverse of the function. You get the inverse of x. Okay, you can easily do that, right? So let's try it. If y is x to the 3, how do you write the inverse function of x? X will be, when you isolate x, x will be what? Y to the power 1 minus 3, or you can write the cube root of y. Oh, it will be like this. This is the inverse function. Okay, then from definition 3.1, you can write the PMF. That will be, what is the PMF? You have 1 over 2 to power x, but what is x now? Y to the 1 over 3. So you just write it or substitute x with y to 1 over 3. Yeah, y will be, what are the values of y then? Y is x to the 3. When x is 1, y will be 1. When x is 2, y will be 2 to the 3, which is 8. When x is 3, y will be 3 to the power 3, which is 27, and so on. So this is how you write the PMF of y, right? And if you want, you can prepare the table for few of the y values. You can even leave the answer like this. This is correct. But if you want to show it, when y is 1, what will happen? 1 to power 1 over 3, which is just 1 over 2. When y is 8, cube root of 8 is 2. So 1 over 2 to power 2 is 1 over 4. When y is 27, cube root of 27 is 3. So it will be 1 over 2 to power 3, which is 1 over 8, and so on, right? So even you can stop the answer from here. If you want, you can prepare the table also. Okay, so this is this example straight away use the definition of the one-to-one functions. Okay, so these 3 examples, they are actually different type of examples. The first one, it's easy, where it is independent of x, only the support will change. The second one, the function is a little bit different, not a general equation type. So you have to figure it out by some computations. Third one, it is straightforward, where you have the PMF and where you have the function y equals x to the 3, and find the inverse function and substitute it straight away to the original px. Okay. So that is the transformation method for discrete random variables univariate case. So the next time I'll discuss the transformation method for continuous random variables univariate case. Okay. Any question so far? Right, and there will be an assignment covering the previous section. Okay, so you can try it also within this week. Okay then, if you do not have any other questions.